Hey, it's Wednesday, so you know what that means.
Morse Code of Weather.
Morse, best day of the week. Meteorologist Jacob Morse is here. Now, this week you're talking clouds.
And you know, a lot of people like to go outside, stare up at the clouds, see what shapes that they are.
Yeah.
Meteorologists, when they do that, they got to identify what type of clouds they are. So we're going to go over all the different cloud types that there are. And maybe you can pick up a few lessons. So that when you're looking at the clouds, you can say, oh, that's a cumulus cloud or a stratus cloud. So we'll go over that in a second. But first, let's talk about how clouds form. So it starts with the water cycle. You need evaporation first. You need water vapor to get up into the atmosphere. So when the heat from the sun comes down on a body of water, that evaporates the water and forms our invisible water vapor that rises through the atmosphere. Now, if there's enough lift and enough moisture with that water vapor, with that rising air, we can get our water vapor to condense once the air cools and expands. So through the process of condensation, our water vapor gas gets turned into our liquid water droplets. Those liquid water droplets form our clouds if there's enough of those tiny liquid water droplets. Now, the water droplets cannot condense on nothing. They need to condense on little tiny microscopic particles called cloud condensation nuclei. Those can be sea salt, dust, volcanic ash, smoke, really tiny, tiny particles in the atmosphere that are floating around. Those water droplets cling on to those cloud condensation nuclei, for example, dust, and form our water droplets that eventually expand to form cloud droplets. And once there's enough of those cloud droplets, then we get our clouds to form that are visible that we see in the sky. But it all starts with the cloud condensation nuclei. If we didn't have those microscopic particles in the atmosphere, we wouldn't be able to form our clouds like we do. So these are the different types of clouds. They're broken down into three categories based on the height that they are in the atmosphere: low, middle, and high-level clouds. So high-level clouds are usually made of ice crystals. Those are cirrostratus clouds, cirrocumulus, or just cirrus clouds. We'll go over each one of these in a minute. Middle-level clouds are altostratus or altocumulus clouds, and low-level clouds near the ground, stratus, stratocumulus, or cumulus, and then rain-making clouds, nimbostratus, and cumulonimbus. So there's prefixes on there, if you'll notice, that are from Latin origins. So nimbus, if that's in the name, that means it's a rainy cloud. Stratus in the name, that means it's a layered cloud or spread out. That's the Latin translation. Cirro means curl or a lock of hair, and that's why some of the cirrus clouds get that name from that origin. And cumulus is an accumulation or a heap, and that's why those puffy cumulus clouds have that origin of that name. And all of these names come from Luke Howard back in 1802. We still use that naming convention to this day. So let's go level by level, starting at the high levels of the atmosphere between 16 and 43,000 feet up. That's where planes fly, 30,000 feet or higher. These clouds are made of those tiny ice crystals, cirrus clouds, those wispy clouds that we see generally on either fair weather days or ahead of a storm system. Cirrostratus clouds are what we see with the cirrus clouds, but on a much broader scale. They fill the whole atmosphere with that kind of cloak or veil-like appearance and can kind of make the sun look a little milky, a milky appearance to the sky because of that thin veil of ice crystals way high up in the atmosphere. Cirrocumulus clouds, similarly, but there's kind of broken up a little bit more, so those ice crystal splotches are a little bit more regularly spaced. Mid-level clouds, so now we're going down between 7,000 and 23,000 feet. Altostratus, those are a little bit thicker clouds, kind of like that veil in the atmosphere, but these clouds are more formed with those water droplets instead of ice crystals. Altocumulus, we have a little bit more of the regular interval spacing between the clouds. There's some patches of blue sky in between those clouds. Now we're on the lower levels, less than 7,000 feet in the atmosphere. Stratus clouds are pretty thick when they're this close to the ground. And cumulus clouds are those puffy cotton candy-like clouds that we see on fair weather days. And they can grow a little bit more in the atmosphere, but they're not producing rain just yet. Once we get to the cumulonimbus clouds or the cumulonimbus clouds, those are the rain-making variety of the clouds. Stratocumulus clouds are kind of a combination between the stratus and the cumulus clouds. They're a little bit more layered, a little bit more spread out. So those are the low-level clouds. But then those cumulonimbus clouds, those are the ones that produce the thunderstorms. They can grow very high up in the atmosphere, stretching from low levels all the way up to the high levels of the atmosphere. And here's a couple of examples of those where you have the cloud spreading out at the top. That's what we call the anvil of the cumulonimbus cloud. And that's when we can get those strong thunderstorms to be produced in those cumulonimbus clouds. Those are the strongest variety of our cloud types in order to form thunderstorms. So hopefully that's some little trivia you can play with your friends if you're going outside trying to identify your cloud types, because a little bit more knowledge there of clouds.
Yeah,
Quick question for my meteorologist friends.
Yes.
Oh, yeah, go
Favorite
ahead.
cloud?
Mine would be cirrus clouds, just because they're so wispy, and usually on a fair weather day too, add a little bit of that white to the bright blue sky.
Okay, Henry?
Cumulus. Cumulus.
Why?
Just because I always like them. That's mostly what we see at home
Okay.
anyway. But yeah, we had some pretty neat clouds yesterday. Lots of folks from Bismarck, Mandan woke up to the clouds this morning. It was kind of covering like half of the town, and another half was practically covered. So it looked pretty neat.
And sometimes with those mid or high level clouds, you can get great sunsets because the sun at its
That's
low
what
angle
I
can
like.
project its colors on those clouds. So that's when we love those
Yes,
mid and high level
We
clouds.
do. All right, good stuff. Thanks
Yeah.
as always, Jacob.